Alright guys, welcome back to another tutorial. This time we're going to cover carbohydrates, lipids, proteins, and nucleic acids. This is actually a follow-up from the last one, so this is our second tutorial of Unit 1. The first one I actually described almost all of these things, but we're going to go in a little bit more detail this time around. Okay, so if you'll remember last time, there are four main macromolecules that I was concerned about. We're going to start again with carbohydrates. Let me get a pen that actually works real quick. Here we go. There. Alright. Carbohydrates. Alright, you guys have probably heard a lot about carbohydrates when people go on diets. This is probably the most talked about one. So these are also called carbs. These are called sugars. And they're also called saccharides. Okay? So all of these things we've probably covered before. They're called carbohydrates or carbs, sugars, saccharides. These are, remember, short-term energy. Short-term energy. They do dissolve in water. That's why our bodies dissolve them so quickly, because we are like 70% water, so our body breaks them down really, really fast. Keep in mind for now, carbohydrates are not necessarily bad. So you guys have heard of them in about them in dieting, and you shouldn't eat too many carbs because they're bad for you. To be honest with you, carbohydrates are actually extremely good for people that are highly active. So at some point or another, for everybody, since they had to go and hunt and run around, and you never knew when food was coming, carbohydrates are a really good thing because you could eat them really quickly, and it'd be like a pick-me-up, all right? So carbohydrates are great for that explosive burst of energy that people like runners are looking for and that kind of thing. You normally burn this off within the next day or so. On the other hand, conversely, are lipids, which are fats, and those obviously take longer. We're not going to talk about them just yet because I'm on page 4, by the way, of your tutorial, and I'm just looking over to see if there's anything else about carbohydrates that you guys need to know. It looks like it's okay. So yeah, all you have now are carbohydrates. Remember, they're sugar, saccharides, and they're short-term energy. I'm going to go ahead and move on to page 5. Let's see what they've got here. Oh, okay, they break it down into the following 3 types. Alright. So you have, and remember, so you had one of these little things, these little hexagons, and I was like, cool, that's called a monosaccharide. Mono meaning one, right? And then you have another one. You could have 2 of them. So here's 2. 1, 2. Kind of poorly drawn, but this is a disaccharide, means 2, right? And then anything more than 2, so this could be like 3, 4, 5, 6, 20 of them, doesn't really matter, but if you have more than 2 of them, they group them all into this thing called polysaccharides. Technically, each of them have a different name, so like 3 of these would have trisaccharides, but you're not going to actually memorize all the different names. Okay, that was really poorly drawn, but you get the idea. This is a poly, as in more than 1 or 2. It's going to be many. Alright, so poly just means many. So you've got your monosaccharides with 1, disaccharides with 2, and poly just means more than 2. Okay, and they gave you a bunch of examples on your tutorial about this. So like monosaccharides would be, so let me make a couple of dashes here on your notes. Monosaccharides are going to be things like, they're the simplest sugar because there's only one part of them. Things like glucose and fructose. You've probably heard of these things. Fructose is a really popular sugar that they use inside of like Welch's grape juice and that kind of thing. So you've probably heard of glucose and fructose. Over here in disaccharides, these are going to be slightly more complex. A lot of your dairies are going to be this. So it's like the sugar that's in like milk, lactose, galactose. So you're going to hear things like lact in a lot of these milk-based sugars and that kind of thing. That's why milk, even though it is good for you, it is highly filling. So this is why babies drink milk. You gain a lot of weight that way because you're taking a whole lot of sugars through milk. So a lot of older people start cutting milk out of their diet because it's hard to digest all of that. And then you have, all sorts of things that are going to be polys. This could be anything like cellulose. This is not to be confused with cellulite, by the way. Cellulite in humans is that wrinkly stuff. Cellulose is that stuff that makes plants kind of fibery, like they're bendy and stuff like that. That's cellulose. You've got, starch. You guys have probably heard of that. All right. So these are just some examples of them. You don't necessarily have to memorize all of them, but remember this: glucose, fructose is going to be mono, and then you're looking for that lact for the disaccharides. All right, so lactose is a disaccharide, and then polys are going to be things like cellulose, and starch, whatever else. Let's see. Let's go on page 6. And they're going to, okay, you saw this picture already on your last tutorial, so I'm going to skip the picture. It's just an example of, you'll notice they show you glucose and fructose and sucrose and starch and cellulose and all that jazz. So I'm going to talk about the actual functions here. Carbohydrates are largely the amount of energy that you get. Your tutorial says 75%, so we'll go with that for now. That number is actually a little different according to recent research, but that's okay. So 3/4 of the energy that we get is from carbohydrates, and this is where you get like your fastest energy. So this is why people before races and whatnot, they'll carb load, or before, like if you've ever been a track runner or if you've been a swimmer, most guys and most girls will have like a bunch of pasta the night before. Like they'll eat pasta is like the go-to thing. After a race, maybe you went to like Olive Garden or something like that, just because that high level of carbohydrates is really, really good for athletes. It's not so good for everybody else. All right. So you can use it to replenish all the energy that you've lost, or you can use it to store up on energy for the next day. In any case, that's what most people do before and or after an event. Carbohydrates are also super important in developing like structures in your body. So there are two of our macromolecules responsible for structure, one of which is going to be our carbohydrates up here, and the second of which is going to be proteins. So you guys know proteins create muscles and all that jazz, really important in like teens and stuff. As you're growing up, so for adolescents, growing from that puberty area, super important to have a lot of protein in the diet. But carbohydrates are more for structure in plants, namely hard things. So humans don't have that many hard things, like our fingernails are kind of hard, so there are carbohydrates used for our fingernails. But for the most part, it's used more in like plants and whatnot. So wood is really, really hard. It has a heck of a lot of cellulose, and so that forms their cell wall. That's what makes plants so hard. Okay. Lots of bugs also use it. So you know that crunchy sound that you hear in bugs? That's going to be carbohydrates. Alright, question on page 7, you can go and check that out. I'm going to go ahead and go to page 8, where we're going to start talking about lipids. Alright, so lipids, I've never actually studied lipids that much, but at the very least, I need you to know that they are fats. Alright, so lipids is a fancy way of saying fats. They're going to be slow energy. There's going to be like long-term energy. Alright, so think about how hard it is to lose weight. It's because you've stored all of these fats. You've stored them away, and they're going to give you energy later on. It helps in life, or at least it helped back when we were trying to hunt things down. Now that we're just chilling at desks and ordering Pizza Hut, it's kind of hard to. I don't like Pizza Hut, by the way, guys. But it's kind of hard to burn off all of the energy that you otherwise save as fats. Didn't used to be that way. So let's talk about the different kinds of lipids. I think they're going to talk about saturated and unsaturated. We'll see. Interesting. Okay, so they gave you a chart on page 9 that talks about 3 types of lipids, and they talk about triglycerides, phospholipids, and steroids. You don't really need to worry too much about any of these 3, like specifically by name. Just understand that lipids definitely do have different parts of their existence. Phospholipids are probably the most popular that you've heard of. Actually, no, everybody here has probably heard of steroids. Steroids are just hormones, or part of hormones rather. And so hormones are largely fat related. That's why when you have an imbalance of hormones, often you start gaining weight in weird ways. Like puberty will do that to you. Puberty makes some people lose weight, gain weight, whatever else. And it's really, really hard to control your body image just because of the amount of hormones that are moving in and out of your body. They are lipids, so they do screw up with that. Okay, so that's probably the one that you guys need to highlight. I'm going to go ahead and move on to page 10. And they've talked about triglycerides. And they're talking about the function of lipids. So lipids, I told you earlier, they store long-term energy, okay? And this is all stored in your layers of fat. They're also insulators, so they keep you warm and they prevent, it's so that people can't just tap your back and then, I don't know, touch your heart. That'd be really, really weird if your heart was just pressing right up against the skin. So you gotta have a layer of fat, layer of muscle, layer of whatever else to protect it. Lipids do serve that function as well. Okay? And then they talk about steroids being a unique group at the very, very bottom, last paragraph. And that's absolutely true. Steroids are really good for reducing swelling and pain. And then, of course, they are part of estrogen and testosterone. Okay, so we're going to move on. You can classify the 3 types of lipids if you like. I'm going to go over something that's not in your tutorial. So you're welcome to skip this. It'll take me about 3 minutes to cover it, but it's actually fairly important. You have saturated and unsaturated fats. Now, oops, sorry. This is going to show up on your EOCs, so I wanted to cover it real quickly just so that you guys had a general idea of what was going on with them. But when they talk about saturated fats and unsaturated fats, you can probably, it's more than likely that you can guess which one's bad and which one's good for you. Now, they both have their uses. I'm not saying that either one's always terrible, but one of them is generally considered healthier than others. And you probably guessed it. If you know what the word saturated means like soaked. Okay, so saturated means filled up. You want the unsaturated fats. These are the healthy ones. Now, like I said, that doesn't mean saturated fats are all bad. It's just that these are called the generally healthy ones. Okay, and the reason that you know them apart is that one of the let me get you the actual structure of a lipid. So you guys probably saw on the last page that you have something that looks like this. You have like a C and then some H's. Oops, sorry. H, here's an H, and then it's going to connect to another C with some other H's and whatnot. And it's just going to keep going. It's going to repeat the structure. You're going to have all these single bonds, right? So you're going to see all these single bonds. This is just going to keep going however many you want. I'm probably going to stop here. I don't really want to keep drawing it. But it could technically go on and on and on. Now, in unsaturated fats, they're going to look essentially the same. So I'm going to just draw this again. I wanted to find a specific example online, but I couldn't find one that would be easy to draw, so I'm just going to draw it my way. And they'll look something like this, but then suddenly you'll get this weird double bond down here that bonds it to another C. And then it's going to continue its thing. Now, you could have 1 or 2 or 3 of these double bonds, it doesn't really matter. But the point is, if you see a double bond, that is what makes it an unsaturated fat. That is actually good for you. That double bond prevents it from becoming solid so quickly. It keeps it more fluid. Okay, so unsaturated fats are good. So these are liquid at room temperature, but these other ones are solids at room temperature. So you can imagine and think of a lot of different things that you've probably eaten that are solid at room temperature. Things like bacon grease. When you cook bacon and you leave the pan sitting there or whatever, you get all that weird white fatty grease stuff. That is going to be a saturated fat. Unlike that, though, you have the healthy quote-unquote fats that you see in like olive oil and whatnot. So you'll notice that olive oil, even if you were to pour it in a bowl, it would still be liquidy just sitting there. Chances are a bunch of stuff would fall into it and cause it to curdle, but if you were to cover it up and just kind of leave it sitting around, it doesn't turn into a solid. You just kind of stir it around and it's still liquid, right? So that is the difference between these two. This is generally called the healthier one. So it's not going to be on your mastery test, but it should be on your post test. If not, it'll definitely be on your EOC. So I would definitely keep all of those things in mind. Alright, so let's go ahead and move on to page 12. We're going to cover nucleic acids. A nucleic acid is a fancy way to say DNA and RNA. Okay, so nucleic acids are simply, sorry about that. Let's get this on screen. Nucleic acids are genetic material. That's all they are. They are genetic material. And we know genetic material as DNA and RNA. Alright? DNA slash RNA. So that's really all you have to memorize about these specifically, but let's talk about all the little parts. On page 12, they're going to go in a lot more detail than you need to know for the most part. I'm going to go over it in kind of a simplified way. With DNA, you're going to have a very specific set of things. You're going to have cytosine, so C, cytosine, and it's going to pair up with G, guanine. Okay, so these two are going to pair up. You've probably seen the C's and G's before, and we're going to go over what a chain would actually look like, but those are those two. And then you have a couple of others. You have adenine, or A, adenine, A, and it's going to pair up with T, or thymine. So this is how the pairing works, and that's why in DNA you'll see they normally have this double helix thing, and there are a bunch of little ladders. And so each of those little ladders technically points from like an A to a T, and a C to a G, C to a G, and they don't have to be in that order. I can easily do G connects C, T connects A, that kind of thing. And it's just going to keep going, 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 going. Alright, so just remember what pairs up with what. C and G pair up, A and T pair up. RNA actually works the same way. However, C pairs up with G, and that's fine. A pairs up with T. But RNA has this weird extra thing that's transferred over later on. It's called uracil, or U. Alright, so uracil, or U, is the same exact place as T. Basically, in RNA, instead of seeing your thymine like you're used to, you'll often see uracil instead. So just keep that in mind that RNA has one extra thing. It's called uracil, or U. All right. Let's go ahead and go on to page 13. So they go over the differences between DNA and RNA. So we're going to go ahead and add a couple of these to our notes. You'll notice that this one was double-stranded, right? So DNA. Oops, sorry. On screen, there you go. So DNA is double-stranded, like one strand, two strands. Okay, so this is a double-stranded helix. On the other hand, RNA looks like this. It's just like one strand, like that. There's no other side of the ladder. It's just half of the DNA, essentially. All right. So let's see. What else is it that you need to know? Just remember that this one does have uracil. That's probably a big deal. And that is pretty much it. Oh, RNA. This is for protein synthesis, which we're going to talk about proteins really, really soon, but that's going to be the hardest one, so it is set for last. So this is protein synthesis over on the side. This is actual, like, genetics synthesis, let's call it that. So all of your DNA, all of your genetic background is formed by this thing on the left. Okay? Keep in mind for me that nucleic acids are made up of nucleotides. So each of these are called nucleotides. So like C, G, A, T, and U, those are all called nucleotides. And let me go ahead and include that word, nucleotides, right there. Okay, so equals A, T, C, G, and then I guess I'll put U right there. So yes, nucleotides make up this genetic material. Alright, so basically it goes nucleotides, RNA forms DNA, forms essentially U, or a cell, or something like that. Okay, so that's all you need to know. Nucleotides are the bases, all made from, well, whatever. We're going to go ahead and move on. Let's check out page 14. And on page 14 you'll see, as my computer loads, it's going to talk about the functions of nucleic acids. We've actually already talked about this. It's really just for replicating material. So when your body grows, new skin cells, or if you're having a baby, or anything that would need genetic material, which is kind of a lot of stuff, this is what DNA and RNA are responsible for. Alright. So let's go ahead and ask you a question on page 15. I'll leave you guys to that. I'm going to move on to 16. So we're going to talk about proteins now. And proteins are very, very important because here's how proteins work. Now, I did part of my studies in college on this one, so I'm going to try and follow the book pretty closely because I get kind of crazy with proteins and I talk a little bit too much about them. So I'm gonna, like I said, I'm gonna limit it to try and stick to the tutorial really, really close. This is probably only gonna take us another like 5-10 minutes to cover. So proteins have a nitrogenous base. They have an N somewhere in there. It's gonna be attached to some hydrogens, but you definitely have to have that N. So this is largely what makes it a protein, that nitrogenous base, okay, that nitrogen. It's going to connect to carbon, of course. Everything living has carbon, so you have a carbon. And then it's going to connect to something called an R group. And that R group can look like a lot of different things. It's going to be a lot of different letters. You might have phosphorus in here or whatever, but you're going to have maybe an ethyl group. But something. You're going to have a bunch of different R groups, and this defines your protein. Alright, so every protein has this nitrogenous base, and it has, combined with another C, combined to an O, combined to a hydroxide. But, so every protein has all this stuff. All this stuff is completely regular, okay? You'll see that in every single protein. But this R group defines what your protein does. Alright, so they all have different functions. This defines what it actually does. Okay, you guys see that? Let me bring this in. Okay, so that defines what it does. I'm going to go ahead and scroll down here a little bit. Good. So they talked about how the base structure, alright, the base structure, or the smallest unit of a protein is amino acid. So amino acids, often shortened as AA, are the bases of your proteins. I think we talked about these in the last tutorial. So proteins are going to be a lot of your body. Like your body is largely made up of proteins, and you have to remember kind of how they work. We're going to talk about structures. We're going to talk about a lot of things with them. Just remember that they are made up of amino acids. Okay, a bunch of little amino acids. And remember from actually, we haven't gotten there yet. Just kidding, though. These things are produced in the ribosomes, which we're going to talk about ribosomes in an upcoming lecture. So I'm going to skip it for now, but they are made by something called the ribosome. All right. On page 17. So we're still going to cover proteins, so I'm going to keep this kind of like in view, but we're going to talk about something sort of important. Let's see if I can get this all on screen properly. Yes. I need to read this right now. No. Nope, that's not it. There we go. Alright, so if I can get this to be, yeah, that's good. Kind of. Okay, so with proteins, you're going to have 4 different structures. They're going to be called primary structure. By the way, your tutorial is going to do a much better job of this than I'm doing, just because I can't draw for anything. So I'm going to show you how I draw them, just in case you have to draw them for your own reference. I'm really not the best example for this, so you can probably find somebody on YouTube that draws proteins like way better than I do. Anyway, you have 4 structures called primary. Primary means first, so that comes first. Secondary, second means second, whatever. And then tertiary means third. And quaternary, like from quattro, is going to be fourth. Okay? And I don't know why I swallowed my R there. That was really weird. I think I tried to put an accent on it and completely failed. In any case, excuse me for any of my Spanish speakers out there. That was absolutely awful. But quaternary does mean fourth. Okay? So primary. We're going to start with just a very basic structure. It's normally just amino acids tied together. Normally drawn like a string of beads or a string of squares or something like that. That's primary structure. It doesn't have to be straight, by the way. You can actually, whatever, like a snake, but it is just a bunch of beads attached together. Think of like a pearl necklace that's broken, right? So secondary is going to be a little bit different, and this structure is actually really hard to draw, but it's something called, let me see if I can't draw it. Kind of like that, whatever. So it's called a, here's the thing, this is going to normally be called a chain of some, oh god, you guys can't see that. So I'm going to move this up a little bit. Sorry, you guys can't see anything I'm drawing. Primary is this chain, okay, it's like a chain of beads or whatever you want to call them. Secondary, you're often going to hear the word pleated or folded. So it has a pleated or folded structure. Keep in mind these are both still mostly 2D structures, but you're going to hear pleated or folded, and it's just going to have a bunch of folds in it. So instead of being a chain of dots, it's going to look like it's got folds, like a ribbon. Or people always say pleated pants. I have no idea what pleated pants are. I'm still kind of confused as to what they are. So I don't know. You can Google pleated, but secondary structure does have that weird kind of fold in it. It's still 2D. All right. Tertiary structure is different. Now, tertiary structure is going to be your first 3D structure. Think of a rope or a shoelace. Okay? A rope or a shoelace would be exactly what we're talking about when we're talking about tertiary structure. It's just going to be a 3D little rope. All right. And quaternary, think of a lot of different ropes. All swirled together in this gigantic, messy looking knot. All right. So like, here it goes. So my drawing is awful, but you get the idea. It's just supposed to be a 3D thing of string. Yeah, mine was awful, but the idea is it's just a bunch of different strings together. Okay, so let's go over that real quickly again. Primary is a chain. Secondary is going to be a pleated or folded structure. Tertiary is going to be like a rope. So this is your first 3D structure. It's a single rope. And then your quaternary structure is going to be a 3D structure, and it's going to be a bunch of ropes. Okay, so if you keep those in mind, you should be able to keep them straight. We're going to go ahead and move on. Again, that's page 17 in your tutorial in case you need it. Page 18 covers denaturation of protein. So denaturation is actually a very important part of denature. Denature just means to break down. So the breaking down of protein is what denaturation is. Breakdown. Alright. And what happens with proteins is that they're used for a lot of different things. So that R group decides what you end up doing. Some proteins are for building muscles. Some proteins are for enzymes. So proteins can be for, let's talk about this. So proteins can be for muscles. I know I keep doing things off screen today. I don't really know why. I'm like looking at my paper way more than I normally do. I guess it's because I drew things. I'm not used to drawing things. Anyway, so proteins can be used for muscles. They can be used for enzymes. Enzymes, by the way, just speed things up. So they speed stuff up. Reaction specifically. I'm going to say speeds stuff up. Okay? So muscles, enzymes, and they're also used for they're in genetic material. They're all over the place. They're used for pretty much everything. They're used for structure as well. So just keep in mind that they have a lot of different purposes, but this denaturation is going to happen whenever they're used up. Sorry about that. That was a bell. Okay, so sorry about that bell. I'm over at Ridge right now, so they ring bells now and again. But enzymes, when they speed stuff up, often get denatured. That just means they get broken down after they, are used up. What else do proteins do? They Oh, okay, and they gave you an example of a denatured protein. It's often very, very visible. So on page 18 of your tutorial, they talk about how when you take an egg and you break the eggshell and you put the yolk in a pan, you heat it up. As you heat it up, the egg changes color, right? So that is denaturation. Okay, so let's take a look at page 19. So we're going to talk about some functions of proteins. So this is actually useful. So I'm going to add this to here if I see anything. But they talk about enzymes, so they speed stuff up. Proteins also transport things through the body. So some proteins are just responsible for moving all of your stuff to different parts of your body through the body. Alright, you guys still can't see that. I really need to there we go. Kind of. You guys are kind of on screen right now. So they're used to move things around in the body, and that's actually really important because of something we'll go over later on. We talked about muscles. Oh, and there's one more function. Antibodies. Your antibodies, like your T cells and such like that, these are going to be made out of proteins, and they are specifically for sickness defense or illness defense. So they protect us from foreign objects, that kind of thing. All right. So these are the functions of proteins that I'm going to have you guys focus on. Let me go ahead and go to page 20. They ask you a question. I'll leave that to you guys. And 21 is a summary. So looking over your mastery test, your tutorial did cover it really briefly, but even I ended up skipping it just because I didn't think it was all that useful. But couple things that I want you to note just for your mastery test. There's a protein called keratin. Keratin only exists in the 2D, only 2D. Alright, only 2D. So with keratin, I want you to remember that it is only involved in the secondary and the primary types of proteins. Alright, so keratin is secondary and primary level only, and primary level. Okay? So as things get more complex, as proteins get more complex and they grow up, their energy increases. Okay? They also become more unstable, so it's a lot easier to break this down than it is to break this down. To break this chain is actually really, really hard, but to untie these ropes is fairly easy. Okay, well, comparatively. In any case, if you have any other questions covering this material, feel free to message me as always. This one actually does have a lot to it. This is actually very EOC relevant, so I actually highly recommend this chapter. Let me know what you think, and thanks again for watching. I'll see you guys next tutorial.